Hey guys, this week we did just one question to trigonometry to start, and then we jumped straight into the circle, coordinate geometry of the circle. So we'll just get this question out of the way first, and then we'll jump straight in. Okay, so this question says the diagram shows a triangular prism. The base of the prism is a square, side length 15, and they've already told us, but that means because it's square, this side length is 15 as well. Okay, angles ABE, ABE, and CBE are right angles. Oh yeah, so they're just saying that that's a right angle and that's a right angle. Okay, and EAB is 35. Okay, EAB is 35. Calculate BE, so this length here. Give your answer to one decimal place. Okay, so we want this length here, so let's call it X. We know nothing about the hypotenuse, and it's a right angle triangle, so we know an angle and a side. So that should lead us straight away to thinking about trigonometry and the triangles like this. So if this, imagine this is a triangle, this was 15, this was 35, and this is x. That means we can get this side by doing the sine of the angle and multiplying by the hypotenuse, but here we don't know what the hypotenuse is. So what we're going to do instead is we know this angle, so we can use the tan and then multiply by this this side here. So that means tan 35 multiplied by that side is equal to x. And whatever that happens to be, if I get out a calculator, 15 tan 35 is going to be 10.5, so 10.5 centimeters to one decimal place, yeah, 10.5. Another way you could have come to this conclusion instead of using the unit circle would be to think about SOHCAHTOA. So straight away we see we have nothing to do with the hypotenuse, so both these are gone. So that leaves us with TOA, and we know that's tan of the angle, whatever that is, so 35, is equal to the opposite over the adjacent. Here the opposite is x, and the adjacent is 15, and then we just multiply it across by the 15 there. So that's one way to think about it as well. Okay, so then the next question says, calculate the volume of the prism. Give your answers to two decimal places. Okay, when we think about length, area, and volume, they're kind of different dimensions. So length is just kind of one-dimensional, it's just one line like that. Area is two-dimensional, like this side of the triangle. And then volume is three-dimensional, so it's everything in this kind of prism. And one way you can think about area, length, and volume is if you take a length, so one-dimensional, and you multiply it by another length, you're going to get an area. And then if you take an area and multiply it by another length, then you get a volume. But I'm sure you know all that. The way I like to think about it sometimes is if we take little slices of this prism and then add them all up, then it's going to give us the entire volume of all the sphere, or the prism. And what the slices we're going to pick are just going to be this area of here. So if you take this slice and this area of this triangle on the right hand side and then multiply it across all the way by 15, then we're going to get the volume. Okay, so let's get the area of this triangle, and the area of a right angle triangle is just going to be half the base. So I have 15 times the height we just got, 10.5. So that's going to give us 7.5 times 10.5, which if we put into our calculator, 7.5 times 10.5 is going to give us 78.75 centimeters squared. And now we just have to multiply this by 15 here to get all the slices added up. So we multiply that by 15, we're going to get 1181.25 centimeters cubed. Okay, great. Very last question, calculate DE, the length of the diagonal from the vertex D to the vertex E, so this one here. Give your answer to two decimal places. Okay, so this is where I've been telling you to kind of draw your own diagrams, because if we look at this diagram here, you can see that, you can see that this angle here, DAE, doesn't look it looks past horizontal, or it looks past 90, it looks obtuse. But if we think about it, A and B are in line with each other, so we can write that as AB sort of. This is the point E up here, so that's in line with A as well. That's straight up. D is in line with A, so this is D, and then that one's the red one. Oops. And so that means that this is a right angle triangle, and we can just figure out the hypotenuse that way. So if we know this length is 15, how are we going to find this length? Well, if we can find out this length, we can just use Pythagoras. So let's do that. How are we going to do that? Well, this length here, let's color it in green, is part of another triangle, ABE, where this is ABE, and this is also a right angle triangle. You know, this is 15, we figured out that's 10.5, so how are we going to find x? Well, let's call it y. How are we going to find y? Well, we can use Pythagoras' theorem, so 15 squared plus 10.5 squared is equal to y squared. Y is equal to the square root of 15 squared plus 10.5 squared, and that is equal to 18.31. Okay, so this is 18.31, and now how are we going to find x? Well, x is just going to be another Pythagoras, so 15 squared plus 18.31 squared. X is equal to the square root of all that. 15 squared plus 18.31 squared. So that is 23.67 centimeters. And so that is the one we want, DE. Fine answer. Okay, so that's just a quick trigonometry question. We'll keep tipping away at those if they come up. But yeah, so next we moved on to coordinate geometry of the circle. Okay, so the first question we did said, circle S has center C1, 1, 3, and radius length 5. Find the equation of circle S. Okay, so we know an equation of a circle can be written like this. X minus g squared plus y minus h squared is equal to r squared. Okay, great. Where g and h is the center, so we can just plug those in. So that's 1, 3. So x minus 1 squared plus y minus 3 squared is equal to, radius is 5, so that means 5 squared. Now we just have to multiply all this out. So x squared minus 2x plus 1 plus y squared minus 6y plus 9 is equal to 25. X squared plus y squared minus 2x minus 6y and 10 minus 25 is minus 15 equal to 0. Okay, so this is our equation for the circle S. This could also be the equation for the circle S, but because there's two ways of writing them, it's easier just to multiply it out and have both of them down on the paper so that they're both correct, and that if they ever decide to only give marks for the top one, we know we have that down as well. Or if they only give marks for the bottom one, we have that as well. So, perfect. Okay, so next question says, a second circle K with center C2, so this here, and this is circle K, this is circle S, has a diameter 2.5 times the length of the diameter of circle C1. Okay, C1 lies in the circumference of this second circle, and the line joining C1 and C2 is parallel to the x-axis. Find the equation of the circle with center S, or C2, sorry. Okay, so let's use the information that we have. So first thing they tell us, the diameter, center C2 has a diameter 2.5 times the length of the diameter C1. So this diameter here was 5 plus 5 is 10. And this, I'll do it in red, this diameter here is going to be 2.5 times 10. So it's going to be 25. So that means our radius is going to be 12.25. Or is it 12.5? 25 divided by 2. 12.5. Yeah, sorry. Okay, so this radius here is 12.5. Oops, I should do it like this. So this here is 12.5, and this one here in black is 5. Okay, great. What else do we know? Well, from the previous question, we know the center here is 1, 3. Okay, we're trying to find the center of this. What else can we use? The line joining C1 and C2 is parallel to the x-axis, so that means this line here is horizontal. So that means the x or the y coordinate stays the same. We don't go up or down anything. So this y coordinate is going to be the exact same as this y coordinate. Let's fill that in. Okay, and C1 lies in the circumference of this second circle. So that means if a point lies in the circumference of the circle, the thing that joins points on a circle together is they're the same distance from the center of the circle. So that means this center here is 12.5 away from the center. This is the same, 12.5. But we know that the centers lie in the same line, so the y-axis doesn't change. So now the x coordinate is going to change by 12.5. So 1 plus 12.5 is going to be 13.5. Okay, perfect. So now we know circle K is a circle with center 13.5 and 3 and radius 12.5. And this is pretty easy. We just have to do x minus 13.5 squared plus y minus y minus 3 squared is equal to 12.5 squared. And we just have to multiply all this out, write it in the exact same way that we wrote this. Perfect. Okay, next one says, find the equation of a tangent to the circle S at point 2,7 on the circumference of S. So let's draw a quick picture. So this was our circle S with center 1, 3, radius 5. And we want to find a tangent at the point 2, 7. So a tangent is a line that just barely touches off it. Okay, so we need to find the equation of this line. Two things we need for a line. We need the slope and a point. So we have a point already. This point of tangency here, where it touches the circle, is a point on the line. So that's one thing done. Now we just need the slope of this line. And something about the tangent to a circle is that the slope of this line here is going to be perpendicular to the slope of the line. So if we can find this slope here, then we can invert it and find the slope of this line, and then use that to find the equation of the line. Okay, so how are we going to find the slope between this point and this point? Well, that's pretty easy. M is just equal to y2 minus y1 over x2 minus x1. And it doesn't matter which point we take is x1 or y1. It doesn't really matter. So let's just pick this point up here. So 3 minus 7 over 1 minus 2. So that's equal to minus 4 over 3. And that is our slope of this line here in red. So now to get the slope of this line here in green, we just have to flip this slope upside down and change the sign. So that means, let's call it m with a little dash on top is going to be 3 over 4 and change the sign plus 3 over 4. Okay, so now we have a slope and a point. So equation of a line is y minus y1 is equal to m times x minus x1. So that's y minus 7 is equal to 3 over 4 times x minus 2. So if we multiply across by this 4, so 4 minus 28 is equal to 3x plus 6. So I multiplied by the 4 and multiplied the 3 in. Okay, so now 4y minus 3x is going to be equal to, minus 28 plus 6 is going to be 34 is equal to 0. So this is our equation for this line here in green. Perfect. And very last question, investigate if the tangent you found in part 3, so this equation here, was the tangent we found, so let's straight away bring this up. Paste. So this is the one we want to investigate. We want to investigate if it is also a tangent to circle K. And this was circle K, the big one here. So the big circle was center 13.5 and 3 and radius 12.5. We want to investigate whether this line we just found, 4y minus 3x minus 34 is equal to 0, is in fact a tangent. And how are we going to find that out? Well, basically the distance from a tangent to the circle should be 0 because it's just touching it once like this. But the distance from the line to the center point is probably easier to find, and this should be equal to 12.5, because if it just touches it once, that means the single point on the line is going to be a point on the circle, and all points on a circle are the same radius from the center. Oops. And so we have actually an equation for the distance from a line, or from a point to a line, a perpendicular distance, and that's going to be in your logbooks. That's x1 plus b y1 plus c all over square root, I think, a squared plus b squared. And let me just check that. I don't have my logbook. Anyway. Okay, so our a here is obviously going to be, our a is going to be minus 3. Our b is going to be 4, and our c is going to be minus 34. So that's minus 3. Our x1 is 13.5. 4 times 3 minus 34 all over 9 plus 16. And we should, if this is equal to 12.5, that means it's definitely a tangent to the circle. Okay, so let's solve this. So 3 times 13.5 is obviously going to be 40.5 plus 12 minus 34 all over square root 25. So this is 12 minus 34 minus 40.5 is minus 62.5 all over 5. That's equal to, so the absolute value here, we'll make it a positive, so 62.5 over 5. And that is equal to 12.5. So now this line is perpendicularly distant away from this point by 12.5, and so that means it's a tangent to the circle. Perfect. So this is that whole question done, and on to the next question. Okay, so next question said, a circle C has equation x squared plus y squared plus px plus qi plus 43, where p and q are just constants. Given that the points minus 4, 7 and minus 2, 5 lie on C, find the values of p and q and hence determine the coordinates of the center and the size of the radius. Okay, so first things first, there's two parts to this question. We're first going to find the values in p and q, and then we're going to find the center and the radius. Okay, so even looking at the question, we can see that finding the center and the radius is going to be easy once we have it in this form. So we know that this is minus 2gx minus 2hy plus c, and then we can use those to find the radius. But the problem is we have this p and q in the way. So first we need to find p and q, sub them in, and then we can find the size of the radius. Okay, so how are we going to find p and q? Well, we know minus 4, 7, and minus 2, 5 lie on some kind of circle C here. So let's pretend this is minus 4, 7, and this is minus 2, 5. So when points lie on a circle, when you sub them in, they should satisfy the equation. So that means when we sub in this point into this half of the equation, it should equal 0, and so we should end up with 0 equals 0. But we're going to have some kind of p over here, so we're going to end up with like p minus q is equal to 0, and then we can do simultaneous equations. Okay, so let's get started. So let's first sub in minus 4, 7. So x, we're going to sub in minus 4, so that's minus 4 squared. Over c y, it's going to be 7 squared plus p times minus 4 plus q times 7 plus 43, and that should be equal to 0. Okay, so minus 4 squared is 16, 7 squared is 49, minus 4p plus 7q plus 43 equal to 0. Let's add up all these constants. So 16 plus 49 plus 43 is going to be minus 4p plus 7q plus 108 is equal to 0. So let's call this equation 1. Let's sub in the next point. So minus 2 squared plus 5 squared plus p times minus 2 plus q times 5 plus 43 is equal to 0. 4 plus 25 minus 2p plus 5q plus 43 equal to 0. 4 plus 25 plus 43 is equal to 72. So minus 2p plus 5q plus 72 is equal to 0. Let's call this equation 2. Okay, so let's do simultaneous equations. So minus 4p plus 7q plus 108 is equal to 0. Minus 2p plus 5q plus 72 is equal to 0. This might work easier if we bring our constants across. So this is going to be minus 108, and this is going to be minus 72, and now we can times this one by 2 is probably easiest, so times that by 2, so that's going to be, or minus 2 even, so it's going to be plus 4, minus 10, and 144. So now we can add the two equations together, so these 4p's will cancel, minus 10 plus 7 is minus 3, 144 minus 108 is going to be 36. Now we can divide by minus 3, so that's going to be minus 12. Now we can sub back in, so minus 4p plus 7 times minus 12 is equal to minus 108. 4p is going to be equal to minus, so 7 times 12 is going to be 84 plus 108. And that's going to be minus 84 plus 108. 24, so 4p equals 24. P is going to be equal to 6. Okay, so p is equal to 6 and q is equal to minus 12. The next part of our question was to find the coordinates of the center and the radius, and we know that when we sub these in, we can just read them off. So let's do that. So the equation is going to be x squared plus y squared plus 6x minus 12y plus 43 is equal to 0. Okay, so now we know if we write this in the general form, minus 2hy plus c is equal to 0. If we kind of line these up, so we know 6 is going to be equal to minus 2g, and minus 12 is going to be equal to minus 2h. So if we divide by minus 3 or minus 2, we're going to get minus 3 is equal to g, and 6 is equal to h. So that means our center is going to be minus 3h. Perfect. And we know this is c, and we know the formula for our radius is going to be g squared plus h squared minus c. So it's going to be square root 9 plus 36 minus 43. And that's going to be 9 plus 36 minus 43. That's going to be square root 2. Perfect. So now we have our, this should be 6. So now we have our coordinates of our center and the radius. And that is the whole question done. Okay, so now it says a straight line passes through the point A45 and is tangent to C, so the circle C, at point B. Show that AB is 4 root 3 units. This is our circle C. We just found out that the center is minus 3, 6, and the radius is root 2. Let's pretend a point A somewhere down here is point 4, 5. And we know that the line passing through A is also going to be tangent to circle C at the point B. And they don't tell us what that point is. And we want to show that this distance here is 4 root 3. Okay, so how are we going to do that? Well, what do we know? We know this point, and the radius. We know that because B lies on the circle, so it's tangent, it's going to be root 2 away from the center. And we can also see that if we kind of join this up here, this is going to be a triangle. So we know one side of a triangle. We don't know anything about the angles. We know this is a right angle triangle. We don't know these angles, so we can't use SOHCAHTOA. So we're going to need some other side or an angle. We could work out the angle, but we're going to need some other side or some other angle to figure out this side here. And so what we can do is actually use these 2 points to get the distance between them, and this is going to be our side AC. So AC is going to be equal to the square root of 4 minus 3 squared plus 5 minus 6 squared. And that's going to be equal to 7 squared, which is 49, plus 1. So that's going to be square root 50. If we divide 50 by 2, that's going to be square root 25 times 2. And what you can actually do with square roots is split them up. So if you have square root of two things multiplied together, that's going to be the same as the square root of the first one multiplied by the square root of the second one. And square root 25 is obviously 5 root 2. Perfect. So this distance here is 5 root 2. And now we can use this side and this side to work out this side just from Pythagoras. So root 2 squared, let's call this x. Root 2 squared plus x squared is equal to 5 root 2 squared. So it's going to be 2 plus x squared equal to 50. X squared is equal to 50 minus 2. X squared equal to 48. X equal to square root 48. And whatever that happens to be. So that's going to be 4 root 3. Perfect. And that is exactly what we wanted, 4 root 3. So that's the whole question done. Okay, great. So on to the next question. Okay, so next question was the circle K. So this circle here has center C12 and a chord AB. AB is 4 root 3. So this is 4 root 3. The point D3 is the midpoint of this thing. So obviously this is going to be 2 root 3. And we want to find the radius of K. Give your answer in the form of A root B. Okay, so where on the diagram is the radius? Well, the radius is going to be anywhere from the center to the edge, but none of these really help us. The ones that do help us are these two lines here. So these are obviously radiuses because they go from the center to the edge, and we know stuff about A and B. What do we know about A and B? Well, we know that this here is 2 root 3, and this here is 2 root 3. We know this point here is 3, 2, and this point here is 1 minus 2, so we can obviously work out this side. And now we have two sides of a triangle, and we can find the other side. Okay, so the distance DC is going to be 3 minus 1 squared plus 2 minus 2 squared. So that's going to be 2 squared is 4 plus 4 squared is 16. So that's going to be square root 20. So this is square root 20. Okay, which if you could say is square root 4 times 5, which is 2 root 5. So that might be easier. 2 root 5. This is 2 root 3. Now we just need to find this, and we have one side of a triangle, the other side, and we're trying to find the hypotenuse of a triangle. So that's obviously Pythagoras. So 2 root 3 squared plus 2 root 5 squared is going to be equal to, let's call this x squared. 4 times 3 is 12 plus 20 is equal to x squared. X squared is equal to 32. X is equal to square root 32. And square root 32 is 4 root 2 units. Perfect. So we found the radius of K because this here was x. Okay, great. So on to the next part. So this is separate to the other part. So we want to show that the circles C and the circles S touch externally. And what it means for two circles to touch externally, it means that the distance between the two centers is obviously going to be the two radiuses added together. So if we can find the distance between the two centers and show that it is equal to the radiuses added, then we can show that they touch externally. Okay, so let's get the two distance between the two centers first. Okay, so how are we going to do that? Well, we're obviously going to have to find the coordinates of the center and the coordinates of the center. So let's do that. So for circle C, the equation is x squared plus y squared plus 4x minus 2y minus 95. You can see that this is obviously in general form. So x squared plus y squared minus 2gx minus 2hy plus c. So if we kind of compare them, that means 4 is going to be equal to minus 2g, and minus 2 is going to be minus 2h. So 4 is equal to minus 2g, that means g is equal to minus 2, and minus 2 is equal to minus 2h, that means h is equal to 1. So the center of C is going to be minus 2, 1. We can easily find out the radius because that's the square root of g squared plus h squared minus c. So it's going to be square root 4 plus 1 minus minus 95. So that's going to be 4 plus 1 plus 95, that's 100, and so square root of 100 is going to be 10. And for circle S, our equation is x minus 7 squared plus y minus 13 squared is equal to 25. So this is in standard form. So the thing about standard form circles is we can easily read off the center just by changing the sign. So the center is going to be 7, 13, and the radius is obviously going to be 5 because 5 squared is 25. Okay, so now we can get the distance between these two centers, and we can do that by CS is equal to square root 7 minus 2 is 7 plus 2 squared plus 13 minus 1 squared. That's equal to 9 squared plus 12 squared. That's 81 plus 144. That is 144 plus 81, 225. And 225 is going to be 15. Perfect. So the distance between the centers is 15. And we can see the two radiuses is 5 and 10. So the two radiuses added together is going to be 15. And we see that the distance between the centers, and so we can just write distance between centers is equal to the radii added. Therefore, touch externally. And that is the whole question done. Oh no, it's that part done anyway. There's another part that says there are an infinite number of circles which touch circle C externally at the same point that S touches C. Okay, so let's imagine what we're looking at here. So we just showed that if this is circle C and this is circle S, we show that they touch externally because the distance between the two centers was the same as the radius is added. Okay, but you can also kind of see that, if we wanted another circle that touched at this point there, it could look like that, or it could look like that, or it could look like that, and they all just touch the circle at one point. And they just want us to find the coordinates of the center of one of these infinite circles, so they keep going out and out and out. That's not circle S. Okay, so one thing that joins all these circles together is that they touch at the same point, and this same point lies on the line between the two centers. So this point here, maybe I'll do it in red. This point here is obviously going to lie on this line. And in fact, the point of contact of any circle lies on the line between the two centers. So all these centers lie on the line as well. So that means if we want to find the center of one of these infinite circles, they're going to lie on this line here. So if we can find the equation of this line, then we can find a point that satisfies this line, and that's going to be a center of one of these circles. Okay, so let's find an equation of this line. Okay, so how are we going to do that? Two things we need for a line. We need slope and a point. Obviously, we can get a slope, just between these 2 points. So we know the center point of C is, where did it go? Minus 2, 1. Minus 2, 1. And the center point of S is going to be 7, 13. Okay, so m is going to be y2 minus y1 over m2 x2 minus x1. So it's going to be 1 minus 13 over minus 2 minus 7. So it's going to be minus 12 over minus 9, 12 over 9, 4 over 3. Okay, so that is the slope of the line joining the centers. So we don't actually need to swap this slope because remember when we swapped it before, we were talking about tangents and they were at right angles. But now this is actually just the slope of the line that we wanted. Okay, so we have a slope of a point, and now we need, we need a point, but actually the point, we need a point. So we can choose any of these points. So 7, 13 or minus 2, 1, because they both sit on the line. So let's choose minus 2, 1, it might be easier. So the slope of the tangent equation of a line, so y minus y1 is equal to m times x minus x1. So let's use this. So y minus 1 is equal to 4 over 3 times x minus x1 was minus 2, so minus 2 is plus 2. So we multiply across by this 3, so 3y minus 3 is equal to 4x plus 8. So I multiplied by across the 3 and by the 4. So now 3y minus 4x minus 11 is equal to 0. So this is our equation of the line. So now we just need to pick a point, any point on this line here. So we just need to find a point. So let's just pick any kind of y coordinate. So let's say y is equal to 1. That means 3 times 1 minus 4x minus 11 is equal to 0. Let's bring the 4x across. So 3 minus 11 is equal to 4x. 3 minus 11 is equal to minus 8. Minus 8 over 4 is equal to x. So minus 2 is equal to x. So the point minus 2, that was a terrible point to use because that is exactly the point we just had. So we can't use that. Never mind. Ignore all that. So let's pick a different point for y. So let's pick 2 for y. Okay, so 6 minus 11 is equal to 4x. 6 minus 11 is minus 5, equal to 4x. Minus 5 over 4 is equal to x. So the point minus 5 over 4 and 2 is on the line. And this is going to be the center of one of these circles because it's on this line. So it'll probably be here, minus 5 over 4 and 2. Okay, so that is the whole question done. On to the next question. Okay, so our very last question, it was part of a bigger question about John flying his drone or whatever. So let's just pretend we forget about all that and let's just focus on. So they've given us this circle C, and we want to write down the center and the radius of the circle. Okay, so obviously this is in general form. So if I make this smaller, so general form is going to be x squared plus y squared 2gx 2hy plus c. Same deal we've been doing all along. So minus 18 is equal to minus 2g, and minus 14 is equal to minus 2h. So obviously g is going to be equal to 9 and h is going to be equal to 7. So the center is 9, 7. The radius is going to be g squared plus h squared minus c. So it's going to be 81 plus 49 minus 117. And I think that's root 13, but let me just check. Yeah, so this is root 13. Okay, so now we have the radius and the center. Perfect. So next part says, forget about the drone. So if John walks on the line 2x minus 5y plus 28, will he enter into the circle? So this is our circle here. It had the equation over here. X squared plus y squared minus 18x minus 14y plus 113, blah, blah, blah. If John walks on this line here, 2x minus 5y plus 28 is equal to 0, will he enter into the airspace? Okay, so what do we know about the circle? We have circle 9, 7, and we have radius root 13. So what we can say is that if John walks into the circle, then the distance from the center is going to be less than root 13. And if he doesn't walk into the circle, it's going to be greater than root 13. And if he just touches after the circle, it's going to be root 13. So let's go ahead and do that. So the distance from a point to a line is going to be ax1 plus by1 plus c square root a squared plus b squared. So obviously a here is 2, so 2x1 is 9 plus minus 5 times 7 plus 28 over square root 2 squared is 4 and 5 squared is 25. Okay, so this is 18 minus 35 plus 28 all over square root 29. Okay, so 18 minus 35 plus 28 is equal to 11 over square root 29, and 11 over square root 29 over square root 29 is going to be 2.0426, and square root 13 is going to be 3.60551. So obviously the distance from the center to the line is less than root 13, so he does walk into the line. Yeah, perfect. Okay, so by overlapping maps with the Cartesian plane, blah blah blah. So John finds out he's at point 1, 6, and he wants to walk 2 paths like this. So he just touches the circle, and each of these paths have slope of m. So we want to show that the equation of the paths m can be expressed as mx minus y plus 6 minus m. Okay, so how are we going to do that? Well, 2 things we need for a line. We need a slope and a point. We have a point, and we actually do have the slope because it says of slope m to the airspace. So they've given us the slope m, and so we can actually use it. So this line is y minus y1 times m times x minus x1. Y minus 6 is equal to m times x minus 1. Y minus 6 is equal to mx minus m. And then we just need to write it like this. So let's bring the mx across. So mx, let's bring the y across, sorry. Mx minus y plus 6 minus m is equal to 0. Perfect. And so that's exactly what they wanted. Okay. So now we need to find the equation of So now we need to find the equation of these 2 lines. So we need to find out m basically and sub m in. How are we going to find m? Well, we know this center was 9, 7. We know the distance was root 13. So if we say the distance from the center to each line in terms of m is root 13, then we can work backwards and find out m. So the distance from is ax1 plus by1 plus c is equal to square root a squared plus b squared, and we want that equal to root 13. Okay, so our equation of a line is over here. So a is obviously m, b is minus 1, and c is 6 minus m. So a is m times x1 here is 9, minus 1 was b times 7, and c was 6 minus m. And all of that is over a was m, so m squared plus minus 1 squared. And all that's equal to root 13. Okay, so absolute value 9m minus 7 plus 6 minus m all over square root m squared plus 1 is equal to root 13. So absolute value 8m minus 1 over square root m squared plus 1 is equal to root 13. Multiply across by this bottom, this denominator. So root 13 times m squared plus 1. We saw earlier that we can write square roots under the same square root sign. Perfect. And so now, okay, absolute value is distance from the origin. So if this is 2, this is minus 2. This has the same distance as this one. So this has a hidden minus sign inside of it. But if we actually square both sides, minus 2 squared will map onto 4 up here, and 2 squared will also map onto 4. So they both turn into the same answer. So this will give us one answer, and this will give us one answer. Okay, so let's do that. So we don't have to worry about the hidden minuses sign. So 8m minus 1 squared is equal to, the square root will just cancel with the square, so m squared plus 1. So 8m squared is 64m squared minus 16m plus 1 is equal to 13m squared plus 13. 64 minus 13 is 51m squared minus 16m minus 12 is equal to 0. So now we just need to factorize this quadratic and get two values for m and sub them into our lines. So yeah, we'll get two values for m. Let's pretend it's 3 and 7. And we need to just sub those into mx minus y plus 6. So these aren't the real answers. I'm just pretending. So 3 times x minus y plus 6 minus 3 equals 0. So our first equation would be plus 3 equals 0. So this, and our second equation would be 7x minus y, and 6 minus 7 is minus 1. So this would be our second equation. Just pretend. I haven't solved that as quadratic, but yeah. Okay, so that is that question done. I think that was our final question. Same thing as always. If you have any extra ones you want to send on to me, that's no problem. And yeah, I'll see you guys next week.